Good day, welcome back to my channel, and today we'll be doing a CSEC past paper question from January 2014, and it's on trigonometry, right? So let's begin. It reads, the diagram below, not drawn to scale, shows a position of 3 points, P, Q, and R, and it lies on a horizontal plane. PQ is 120 kilometers, PR is 150 kilometers, and angle QPR is 23 degrees, right? So what they want us to do is to calculate, correct to one decimal place, right? The distance of QR. So they want us to find this side here, right? All right. So if you look, we do not have a right angle triangle, right? So we can't use SOHCAHTOA or the Pythagorean theorem. So when we're not we're not dealing with a right angle triangle, we'd use either the sine or the cosine rule. So let's see if we have enough criteria to use the sine rule. With the sine rule now, you only use it when you have a known side which is opposite to a known angle, right? Directly opposite to a known angle. So if you realize we can't, because guess what? We have a known side of 120 kilometers, right? But it have been opposite to this angle, PRQ, but the angle is unknown, right? If the angle was known, then you'd be able to use the sine rule, right? And it's the same for this one with which you PR. If there was a known side, right? Then you could have if there was a known angle, then you could have used the sine rule because you have a known side, right? But in this case, you do not. So you'd use the cosine rule. So now the formula for the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a, right? So with the cosine rule, right, we're trying to find side A. So whichever side we choose as B or C does not matter. So it would be a squared is equal to, I'm going to make 120 kilometers B. So a squared is equal to 120 squared plus 150 squared minus 2 times 120 times 150 times cos 23, right? So to do this, we can simply punch it into our calculator. So it will be 120 squared plus 150 squared minus 2 times 120 times 150 times cos 23. So therefore, a squared would be equal to 3,761.8, right? And to get a by itself, we'll take the square root of a squared, and therefore a is equal to 61.3 kilometers. And remember, it's stated directly to 1 dp. Now, the second part of the question states they want us to find the area of triangle PQR, right? And the area for the triangle, right, would be half AB sine C, right? So it's going to be half times 120 times 150 times cos 23, right? And when you punch that into your calculator, you would get 3,516.6 kilometers. All right, so that's the answer for part 2. And the final question states the bearing of P from Q, right, is 252 degrees. Calculate the bearing of R from P. So let's put in the angle which you know. They say the bearing of P from Q, right? So the angle is coming from Q. So we know that the entire angle here is 252 252 degrees, right? And it's coming, and the bearing of P from Q. So we drew the angle in a clockwise direction because bearings always comes from a clockwise direction, right? And now, being that they're giving us this information, right? What they want us to do is to find the bearing of R from P. So we know that this entire angle here is 252 degrees, right? So the first step to find the bearing of R from P, right, is we need to find the angle which is right here where you see the angle where arrow is pointing at. Because when we draw the angle from P in a clockwise direction, it would look like this. So we already know that this piece is 23 degrees makes up the end part of the angle, right? So we need to find this piece here. So to do that, right, we can first find the angle that is here. So we know that there's a rule which states angles in a circle add up to 360 degrees. So if this is 252 degrees, we can simply take 252 from 360, which will leave us with 108 degrees, right? So we know that this angle right here is 108 degrees. So our other step is to find this piece right here, right? There's this rule which states that interior angles are supplementary, meaning that they add up to 180 degrees. So, being that these two are interior angles, we can just take 108 from 180, right? Which will leave us with 72 degrees. So, this piece here is 72 degrees. So, we're on our way now. So now the bearing of bearing of R from P would be the entire angle, which is right here. So we know that this piece is 72 degrees, this piece is 23 degrees, right? So all we have to do is to add with 72 degrees to the 23 degrees, right? Which will give us 95 degrees. Therefore, the bearing of R from P is 95 degrees. So that's it for today. I hope you learned something new. Remember to like, share, and subscribe, and I will see you next time.